to take off the mill scale, which I said is just this gray crap on top here. It happens when the steel is made. You grind that off, and then you want to grind every part that you're going to weld on. Like if you go on here, I'll grab one of these, better choice. Now you see this right here is even clean. This one's even clean. I would even grind that, just because, just to be safe. Grind it, make it nice and smooth. Like on these plates that you guys are going to be getting, one side's got a real nice smooth cut on it, and the other one's a little wavy, and that just happens when they bandsaw cut it, because they're cutting on an angle and all that stuff. So look for the good side on it first off, which this one's kind of the same on both. This one's actually the better side. So yeah, you're gonna wanna, do you have a piece of soapstone on you by any chance? You know?
Oh yeah,
oh, there you
see
go.
that?
Sweet, thank you. All right, so what I'm talking about, move this gun out of the way. What you guys are gonna wanna remove is from this line over,
Well,
nice and shiny.
How much would you say, Mike? I usually go back about an inch over.
Yeah, it don't get crazy because one of the biggest things that you'll have at a weld test is they're not all as nice as Don. They'll say, why are you grinding up? What are you grinding for? And all that. So you want to minimize your grinding. But you need to know you do have you're allowed to grind. They'll try to make it seem like you're not allowed to because they don't like it. But you're allowed to grind. So just don't go crazy with it. So yeah, we can keep it about an inch over. That's fine, or you can go a half inch. It's just enough because what you're gonna do is you're just gonna, I got a line on that side. You're only gonna be coming maybe an 1/8 inch over on each side. So that's all you need clean, but you wanna make sure everything, you wanna be safe. So like I said, grind that off. And then also, you guys are doing an open butt on this. So that means you're going to be basically filling a gap. So the back side needs to be clean as well. You're gonna be welding from the front. It's gonna be burning through this part of the metal, and then it needs to be able to solidify and burn into the back. So you gotta clean.
And one thing also is that heat in that molten metal will pull that mill scale into your weld area.
Mm-hmm.
And that's why we cleaned it up really good. So.
And again, that might not make it fail, but I'm not gonna take the chance, because I mean, it's money. If you don't get the job, then you don't get any money, and you're there to make money. We're not welding for fun. So you want to grind front, back, along the bevel. If it's wavy, like this one is, I don't know if you guys want to pass it around. You can see the waves on it. If it's wavy, take your grinder and smooth that out. Because it sounds funny, but it's so small of a wave. But we're talking like thousandths of an inch here. So if there's a bump that's 1/1000 of an inch high, I mean, that's pretty high for that process. Your wire's going in, it's gonna be hitting at one point, and if you got a hill on there, it's gonna be hitting at a different point, which is basically like messing with your machine while you're welding it with it, like turning your knob up and down is what that's like. Do you have a question?
Yeah, I did. As a welder, can you use is there like a leveler? You can use it to check your metal before you.
As far as
like you was talking about, if it's
the
wavy
bevel?
like that, yeah,
The
the
bevel?
bevel.
Yeah, you can, when I was in the apprenticeship with the pipe fitters, we can make them. It's supposed to be, is this one 37.5?
That's roughly around 35, because they have a variable between like 35.5 degrees plus or minus 2.5
Okay.
degrees.
Yeah, you can just, whatever the bevel has to be per test or code, you can make a thing out of a piece of sheet metal. Cut it to the right angle, and then that way you can run it along. We can make that, yeah.
Oh.
There is something you can make.
Yeah,
You just have to make it.
Or either you can have a protractor.
You
have
can do
a
that.
protractor and set it on that angle and check it with also. But a lot of times when the material is prepped, they pretty much.
It's usually right on. With a test plate, it's gonna be good.
Yeah.
So most of the time it's gonna be good, but like I said, you need to check that. You gotta check everything. You should have, I mean, if you want to, write a list down and bring a piece of paper in with you and make sure you mark everything on there off.
All the steps.
I check this step, that step, and this step, and that step. Because then, all you have to worry about is your weld puddle, your travel speed. Talking about Walt Sisler, I was telling you, Janae, about the welding instructor I had, Walt Sisler. He said that there were 4 things that if you do these 4 things, you should be able to do a good weld. And that is amperage, rod length, rod angle, and your speed. If you can do all 4 of those, you should be able to do a good weld. You want to minimize it to those 4 things. You don't want to have, oh, well, there's a crappy gap over here, and now I got to worry about putting a weave on it to fill it in so it doesn't, because what MIG will do on the back, if you mess up, it'll just grape over because it's so constant. The wire's slamming in there, and it'll just keep going. And there is no stopping or manipulating it. Like with a stick rod, you can kind of like step up to kind of get it off or pull back or whatever. With that, it's burning in there, and then when you pull back, it's like turning the volts up, so it's gonna just burn a hole. So you wanna have everything perfect. You're not gonna have that problem with Don coming in there and saying, hey, don't do that. That's not gonna happen here, but it might happen in the field. Just know that you're allowed to do that. You had a question?
Yeah, when you go to take these tests, is it like very strict and timed, or
Yes.
like it is
Yeah,
timed?
Timed, usually. Well, it's been a while since I've taken a test as far as at a manufacturing plant where they do a lot of MIG welding on sheet metal and stuff. It's been a while since I've done that. I've been doing pipe fitting for the last, 2005, 13 years. Those tests are timed. Like a 2-inch Schedule 40 or double extra heavy will be, say you're doing a stick test, that'll be 3 hours. So you have 3 hours to do that. If it's a super coupon, you get 4 hours. Some tests are bigger and you get a lot more time. Depends on the test. So it depends on where you go, first off. Then it also depends on what test you're taking.
Would you say it's a tight schedule, or you got good?
No, you got a good
ample
amount of time.
to go set
Yeah.
up and prep, and,
You got the time to do what you need to do.
and there's somebody
'Cause
watching you the whole time.
Yeah, they'll watch, and they're
completely
they're not
over your
watching
shoulder?
to see the way you walk around, and that guy's got whatever. They're looking at, are they being safe? Because that's first thing is safety, and then they want to make sure that these tests will have parameters on them. Okay, you're not allowed to have a certain buildup and stuff like that. So this right here,
Certain amount
this
of
is the one I was trying to keep. The reinforcement on the back usually is between flush, which is right along flush with the base metal, and 1/8. Now those, they do change. There was a test I just took 3 weeks ago or something where they wanted flush to 1/16, and that's because it was going on the boiler wall inside of a blast furnace. So it does change, but they're looking at that. They're not looking at well, if you're standing there for an hour grinding, yeah, they're gonna come in there and say, what are you doing? But I mean, if you're grinding and it's in a good amount of time and you're doing everything safe, they're not worried about that. They're worried about you taking the proper steps. And that's what I mean. Who cares if somebody says that guy's stupid because he brought a piece of paper and marked it off? You're gonna be the one making money. That guy's gonna be probably failing the test. But that's usually how it goes. But yeah, I mean, you have a list of things you need to do. It's just like cleaning your house. It's just like, I just started playing the guitar, so it's just like playing, everything's gotta be a certain way. So you do it all the certain way, and then you worry about your puddle, your angle, your speed, and that's all you gotta worry about. So you think about having the least amount of stuff on your mind as possible. So anyway, I don't wanna keep going on the grinding part of it.
Well, right now, so Mike could go ahead and give you a demo on how to prep your material.
Yeah, I'm gonna prep I'll prep, I gotta prep two of them.
Excuse me, I keep,
You call me Mike, but everybody does, that's fine. We almost look just alike.
they're just, Mike is his brother, and they're both welders, Mike has sort of got away from the pipe fitters because
Yeah, he left.
He likes, the other factory, various types of things, but anyway,
he's-
I get them mixed up all the time myself. But make sure everybody has their safety glasses on. We're supposed
You
to
know
have
what, I might
safety
need this again.
glasses on.
I'll keep that a little bit longer.
When we're in the shop here anyway. Big plan,
Have you guys found on metal yet? Have you been grinding on anything yet?
Just the table.
They have experience grinding the
stuff off, okay.
off the tables to keep them straight, so.
Yeah, we didn't grind it on the first two.
No, I did a little bit.
Yeah, so you can just go through, prep it up instead of coupons, Mike, dressing the bevels and getting everything up.
I'm gonna start with a different one. Now this is something that I do from the beginning, is when I get my coupons, because usually they'll have a little area with the stuff you gotta grab that's all been certified to be tested on and everything. So whatever plate or pipe or anything you grab, they can be messed up from shipping or whatever. So you wanna check that too. So I usually just take it, like if I'm doing this test, if I was coming in here to do this test, you wanna take these plates and you wanna try to line them up with each other. And you don't wanna have any gap in between it, but you're gonna more than likely have a gap. So what I'll do personally is, like if you see this right here, it's got a little bit of a, it's got this going on with these plates. So I'll just like kind of put a little line on there. That way I know how to know that I gotta grind just a little bit further there. But we're not gonna get crazy on that. So let me grab this, put it on. Grind. Goofy hood I got. Alright, I don't want to give you guys any bad habits. So I'll do this the right way. Actually, to start with, you want to go on that bevel that I was telling you about. What side is that?
Only in the mirror.
This one.
I mean, it's a better angle. Not the proper education for young.
Now you guys, you're not allowed to change the angle of this. So remember that. But like I said, you'll have an actual certified plate and stuff to do it on. But you can't, if you change this angle right here, this bevel, if you change that and make it a different angle, you'll fail the test. They won't even let you tack it. They'll say, not allowed to do that. But it's not gonna be like that. So actually, I'm just gonna do it just to get it right for showing you guys what to do. So anyway, like I said, you wanna keep your grinder with the same angle, don't change it. Just smooth it out. Because they'll have on tests, they'll have, I can't remember what it's called. What's that, the protective? It protects the metal from rusting.
Oh, there's like a,
It's
like
a
film.
Yeah, it's like a film that's on there, and they claim that you can weld through it, but I've never taken the chance. I've always gotten rid of it.
That's another thing, if it has that there oily, like protective stuff on it, that's where we take it, put it with acetone.
I actually will. I just use alcohol,
Well,
but you can use
maybe
acetone's better.
natured alcohol.
Acetone
rubbing
is better.
alcohol, man?
That's usually what I carry, is just rubbing alcohol. I carry it in my bag, but don't let them. I mean, you can have it, so just try to keep it away because it is flammable and stuff. Just take it. You want to wipe all that stuff off. Like this right here. These even have a little bit of oil on them. Especially the sheet metal you guys were doing. That has a lot of oil on it.
Yeah.
Get rid of that. You want to wipe that off. Even if you only have a rag, just get it out of there because you'll get
Remember
porosity.
we taken that and wipe that oil stuff off before we.
Like I said, there's steps. So my step is make sure this is good. Now I got to grind this back. What you do need to know is, let me go back on this angle again. You got to make sure that when you're grinding this, that you don't accidentally start changing, like rolling into that, because that's going to create all kinds of problems. You'll have the metal waving and everything. So ideally, you want to keep the exact angle as that. And I mean, I could show you guys some, because there is techniques to grinding. I know it seems like there isn't, but there is. Look, sometimes you'll get a really good fitter when you're out pipe fitting. He knows how to grind, everything's great. Sometimes you don't. And then you got to do it all. All right, so then, like I said, you just want to take this back. You can go ½ inch, inch. We'll go with an inch just to make sure it's right. And when I say grind it, I mean shiny, because you'll hit it like this, and you'll still see little bits of mill scale in there. You want to get rid of all of it, so it's all got to be taken out. I don't want to hit you guys with sparks.
Yeah, so just watch the sparks flying back that way.
Real quick. And then I'll just.
And another thing that what Charles doing there, notice that he tried to stay as flat as possible, and he didn't roll that grinder back.
Yeah, you want to try to use the you don't want to use the very edge. If you keep it flat, that works out real nice.
Round off that.
Like I said, there's actual ways that you learn how to grind things and how you make it. You can make a really good bevel. And the better this is, the better your weld's going to be.
Now, I just noticed that with that last one, you just said at least about an inch.
Yeah, just to save time, I'm not going to go. I mean, like I said, you got it. We're only coming across wherever that plate went. I did. You're only going to come. It's only going to burn through a little bit, but you want to be safe and just
You
get it
figure
out of
you
the way.
might be an eighth on each side of that after.
Probably.
But just to be on the
But,
safe
I
side, I
mean,
go back a little bit further.
I wouldn't get close with it. Just get it out of the way. But just don't stand there and shine the whole plate up, because then they are gonna say you can't be doing that. Sorry, bad habit. I gotta not do that.
What would you usually do? Just hold it in your hand?
Usually I just put it on the end of the table and do it, but I shouldn't.
Yeah, see, a lot of times. We
It's
might
from
just
being
hold
out
it
in the
into
field
table
and stuff
do it,
like that.
But to be safe and not familiar with the grinder, you don't
And-
want to get your hands and stuff in the way. That's why. it's
And
supposed to
actually,
be
on
safe way.
a test in here, you don't want to do that because you're putting your problems of just moving around, your little movements you do, that creates problems on the metal. You might slip and grind it, and you're only going to get one plate to do. And if you got a big gouge in it, that's going to be a problem. You're going to say, why is there a big gouge in it? And you're going to fail because of that. They will fail you for that.
What we'll have is, we're gonna have some of these vices. I'm gonna make a little grinding station, so we can have the vice mounted on it, and you can do this grinding in the vice.
This is actually what I would use, but I'm not going to go over there because it's hard to see. But that's what we used in high school. That's what I used in college and
And
the
we can show you
apprenticeship.
how to set up with that vice later.
That's easy to do it. This right here is ideally for the situation. So this side's usually a little bit harder to get the crap off it. One thing a lot of people don't realize either is that when you grind, it's leaving a little burr on the end of the metal, and that's metal that's going into your weld. Like I said, you might pass X-ray, but if they pull a bend test out on you and you got stuff like that in there, it's not gonna pass, it'll break. So you wanna take your file, you guys should get a file. Usually a flat file or
We
a
have
half
something
round
back.
file, something like that, it's usually good. And you ain't gotta go crazy, just take the burr off. And there'll be usually one on the back too.
Did you put your land on it, Mike?
What's that?
Did you put any land on that yet?
Not yet.
Okay.
I want to make sure they know about that burr. Because MIG welding needs to be clean. If you're doing a 60-10 on stick welding, it's different. We'll burn right through it. All right, so
Oh, that's the mill scale. Oh,
tweaking this out right here
On that back with the file?
and trying to get the heat set. That's what I was trying to do. I was using a gap and land that I need to change. Do we have any 332 in here?
330?
Yeah. Well, you know what? We'll go with what we're gonna do is we'll go with a light eighth. 332 to 1, you know, light eighth.
332 route over here. I'd rather take it not.
Okay.
Something that James and Judge.
You gotta burn through that while he's getting that. I'll hurry up. Is it this one? Do you guys like welding?
Yeah.
Did anybody guys got a job yet? I know some people. I can get you guys jobs probably. I'm gonna work on that. Yeah, between Don and I, you guys can get these tests under your belt. If you guys can do this test, there's no reason you can't get a job. They'll hire you for that. There's a lot of people that can't do this. Thank you.
Got a So, yeah.
Another thing, and we have some bare wire in here, it says 332, so I'm gonna take and cut up some sections, so everybody, have that with them. Keep with you all the time in your box, and Mike will show you how to, when you grind your, what, we call it land, in the book it's gonna be called your root face. So, you know, the construction terms, everybody calls it, we call it the land.
Your land.
Land, AKA roof face. All right. Hit this real quick.
Another thing you guys bring up. Oh Lord, what was I gonna say? I'll remember in a minute. Okay, so right now, this, like Don was saying, in the field you'll say land, so your root face. Now, again, this, you guys can change this a little bit, but what I like to do is I like to do a 332 root face with a 1/8 inch root opening. And if you guys are having trouble understanding it, that's basically the gap you're gonna fill is going to be 1/8 inch wide, and you're giving yourself, the purpose of the land is there's gotta be a place for the metal to stay. It's gotta go somewhere. And
I'm sorry.
No,
Is
it's
the
all right.
land, just any welding spot that you're welding, or is it a
no, your land is on your beveled
It
plate
is on the
or
bevel.
pipe.
If you look
On
at
the
your
bevel.
books, it'll show you a diagram that explains your,
Yeah, if you guys got a
angle,
book, that's a
bevel
good way.
angle, your
We do
fluted
have a
angle,
book.
Okay.
It'll show you your root face and root opening terminology, so review
That
that portion.
requires reading.
Yeah, this right.
You'll see a picture, we can go over that.
This will always be your root face, what I'm gonna do right now. And it'll do the same thing on pipe. This pipe's beveled, it's just round. It's round plate. So like I said, I'm gonna take this rod, which is 332, and I'm putting the width of this rod on this plate. If you guys can understand what I mean, you'll see what I'm doing here. Again, when you go to do this grinding on here, you know, don't just go, because it's gonna take a lot off because there's not a lot there. So you wanna come in with a little bit of
Just finesse it in.
finesse it in, and just kind of just real light, like. And I've always gotten straighter lands on plate by going in one direction only, going from here back,
Yeah, instead
from
of
here
going
back.
back and
Because if you
forth.
go like this, you can still make it straight and everything, but you're gonna start to make mistakes and that you don't know about. And
So
get-
basically, just go ahead and just let it glide.
yeah, you just want
Yeah.
to real nice and like. I mean, you got to put a little bit in there to be able to. Once you start taking that knife edge off, and gets down to the actual metal, it's wider and wider. But you don't want to go burn the weld grinder up. It's going to create problems. And you guys, you'll be able to do it no problem once you start doing this. So like I said, one nice little. You guys should carry up. What you're gonna carry is this. Make your guys self one of these things. This is gonna be your root opening. And you should have two. Actually, you should have three, depending on what you guys wanna do. But,
Another thing, also like when Sean took and dressed the root face down, you're going to drag that file back across that back side.
oh yeah, I'm gonna, once you figure out your gap is right, or I mean your width is right, that's what you wanna do is just lay your rod. You can even, if you got a longer rod, you could lay it on there. And you shouldn't see any metal, like shiny metal. So that lays on there, and that's how you want to do it. But this is deceiving. You want to take your file, like Don was saying, and just real nice and light running along that side. And right here too. And then you want to just take your hand, not with your bare hands because you'll cut yourself, and just make sure there's no burr on there, and then go back in there and
This is
measure to
really
see if it's
about
all right.
Prepping and then
Right, you know, if
visualizing the
It makes
actual
sense
well
now
with
that I'm
that
looking at
rod.
it.
Is that what you're saying?
It's giving you the instruments to use
This is
keep
your
the proper
gauge.
fit.
This is how you gauge if you're wide enough.
Okay, I just was clear for myself.
And you wanna, another thing, guys, kinda show you how to, what's up?
Quick question. So you're telling me this thing determines if it's, you know,
This is just, like a, I don't know, like a ruler to measure. You just wanna you want your land to be the same width as this rod. Okay? So when you lay it on there, you shouldn't see any, that's exactly what you want, right there.
The other wire that it has is a 1/8. We didn't have the bare wire, so I took the 1/8 welding rod that we had in the back. I knocked the flux off. I took the file and I shined it up a little bit. Like I say, Sean likes things a little bit tighter, closer. I use a lot of times. That's how wide I'll put my gap in sometimes. It's the next size up. You have a 1/8, 5/32. So depending on how your metal can shrink up, if you're having trouble, getting your penetration, your root pass in, there's some things that you can do. You can change your prep a little bit with your amount of land you have, more or less, because you do have some variables in there for that. And also because if you are a little bit tight, you have to work with your machine, with your voltages and wire speeds. And if sometimes the heat can shrink it up, so you're actually tighter than your 1/8. So certain welders, certain people,
And that'll
that's a
also
variable.
determine on like what they actually tell you to do on the test, how much they want. So if they want a heavy bead on the back, then you'll want a wider gap.
Wider gap.
But with the wider gap, you'll have to
A
start
little bit more.
weave in there to spread that
it out,
wire out,
yeah.
to lay out there. And actually, that's probably the best way to do it, like that. But I don't want you guys to have too much to think about. If you gotta worry about really, weaving it out, this is the same thing as that. It's just a smaller land and a thinner
A little tighter.
gap. He's got a wider gap with a thicker land. So he's given that gap right there, he has to give his weld a thicker spot, a thicker land. That's why it's called a land, 'cause that's where the metal's landed to lay on. So that is the type of thing that when you guys start doing it, then you can start tweaking stuff around a little bit. Like, oh, I'm having problems with this and that. So we got the right width. Let me just real quick put one on here.
Now, he can go through that one pretty quick, because he's pretty much explained the other one, so.
Yep, just put it real quick. Another thing real quick I want to say about this, make sure that this is a 90-degree angle. So it should be 0 degrees, 90 degrees. You don't want to have a land that's got an angle on it. Side. Yep. All right.
Natural to you.
Do you guys have a skinny piece of sheet metal or something? You know what? I could probably do it on this. Let me-
That's as small as you got.
I think I could probably do it on this. You guys are gonna have to have a nice flat surface. Are those separate from each other? Yeah, you can do something like this. This should be wide enough. Hopefully wide enough. Yeah, that's good. All right. So the reason I put them piece of metal on there is because you want a nice flat surface. Because you don't want these two pieces of plate to be at different heights from each other. They need to be perfectly across from each other. Because then you'll burn into one side and not get it on the other, which make you fail the test.
Can you use magnets on the test?
On a test, I don't know if you would want to use a magnet because I don't think it's very practical. You got that pulling that. You could, I mean, if you could make it work.
What about the clamps?
As far as
Like
But,
clamping it?
fitting it up, and I have used clamps before.
I mean, sometimes when you tack it, it'll come up or down. You can, whatever gets you to having these flush from each other is fine.
Because that's the most important.
The way I do it is I just put a plate, I usually will make myself a little piece of sheet metal, cut it out, and that way, spray some
And then
no,
anti-seize, or not
whatever,
anti-seize,
anti-spatter on it,
Anti-spatter.
and you can just keep cleaning it off.
Okay.
So yeah, I mean, if you need to use a clamp, if that gets you to where you need to be, that's completely fine.
There's sometimes what I would do is, I'd take and put a piece of, like a flat bar across, I'd take a C-clamp and snug it up a little bit, make sure my gap is still good again. I can tighten it up, because in the beginning, like you say, with less experience, if you go to tack it, and the plates move on you, and normally have a tendency of, well, it's okay to tack the other end. And how many people in here seen when they tack their 1/8 plates together, you had what I call the high-low? Okay, and this right here is very, very critical and important. Well, any of it is. But this right here, if you have that little bit of high-low, you're gonna take and fail out. They'll even look out high-low on a test.
Yeah,
They're gonna check
that'll make
your-
you undercut on one side and get cold lap on the other.
Well,
That's
what happens
when that
is
happens.
they'll, a lot of times, like, do they come in, and if you, prep and fit and tack your stuff up, do they come in and look at it?
They
and
have,
give a
they'll go-
visual
when
before they,
jobs like Marathon at refineries or nuke plants or whatever, they'll come around with a high-low gauge. I have one, I think it's at home. Anyway, it's a little instrument used to check make sure your pipe is lined up and there's not too much difference between the back of the pipe, so they'll take it around there and it's about, you get, I think a 30-second difference you can have between it. But that changes as well, sometimes you don't have that. But at Marathon, it was, I think, a 30-second either way. So it could be under one way, a 30
because
second.
sometimes a little bit of that piping material, maybe a little bit out of round or something.
Yeah,
No problem
sometimes
with
it
that,
comes
so-
oval or whatever, and then if that happens, then you gotta start doing back beveling and things like that, which you do actually need to learn how to do. So, to do this part, I think you guys should all, well, you guys probably see right there, can't you? Is this thing in your guys' way? All right, I'm gonna get right in this area here, and the gun is gonna come around.
In the chair.
Yeah, I guess. It helps explain a little better. With this MIG gun, guys, every time I take this thing out, you want to just straighten this out
I'm good.
and have a nice
You got some.
loop in it or a straight line, because then you'll start tweaking the liner and stuff, which gives you
I got
problems.
some good zoom. I'll be sure.
Where's those? There they are.
No,
It's like a miniature version of St. Louis.
I remember what I was gonna say. You guys want to always carry a piece of scrap with you to your tests.
You fail.
Yeah, you already
You're
said
leaning.
right
Well,
Well, I haven't tacked it yet, so I'm still good. All right, so when you guys take your gap rod, you want to make sure it's not leaning, because that is not a 1/8. A lot of guys will put it in there and it'll have a lean on it, and they'll tack it thinking they have 1/8, but then when you pick it up, it's not 1/8, it's bigger. Remember, you guys want to make everything as perfect as possible. You put your gap rod in there and you want to squeeze it together. Just run your fingers across two of them, make sure they're flush with each other, and then you want to,
What are we supposed to say?
Shield down.
shields down, watch your eyeballs, what I was always told. Sorry guys, forgot about my little switch.
Some of us have switches in there, we have to figure out if that would be blind.
Let me see this real quick. Another thing I do, guys, with MIG welding is before I start another weld, I always clip the wire. You don't want that big ball on there.
Good job, Matthew.
All right. Cover your eyes, watch your eyes. All right. I'm not gonna get into the feathering of the tacks and stuff right now. because that's a whole nother deal. So what I'm gonna do is I'm going to tack this to show you guys what you're gonna need to be doing. But on a test, you're gonna wanna tack it a little bit different, which can be shown to you guys. After you get one side tacked, you wanna just make sure you got this other side good. Sometimes it closes up a little bit, but that's fine. See, that's not even a...
Shields down.
You see how you sort of pulse that weld in a little bit?
Yeah,
If you
build that
stand
up.
there too long on that edge, you just start melting it away. The longer you stand there, the more weight you're trying to put in there, it's not gonna feel, it's gonna get worse. And another thing you're gonna notice when Mike pulls that wire out, the spacer wire, it's, see how tight that is? Now that's what I was talking about earlier, about your metal shrinking. So it's pulling into that wire.
That's why you gotta have that wire in there, because if you just go without a wire, it's gonna close up and be different every single time.
And you always wanna inspect it real good.
Yeah, make sure you guys go over this. You gotta make sure it's flush and stuff, because you can break it apart. But once you have the inspector come over and check your tacks, that you can't. That's it. You don't have another chance. Then you're ready to go. So then you do your root pass, which will be the first one.
We're gonna have to get some little holders made up to.
Yeah, a little pipe or something. Why isn't it turning?
It's gonna turn now.
Hey, Don, quick question. So when you're actually going out, prior to you get to this stage, is there anything that they're expecting from you as far as the machine setting it up?
Feels good.
They'll give you parameters.
Well, I mean, if they're going for some basic jobs, this right here is something extra that I'm throwing in there. I could have did this class, 160-hour basic MIG, what we're doing here, sent you out the door, and you could have went out there to have your certificate and look for that production MIG welding type job.
Oh, it's just
I'm throwing this extra in there because industry highly recognizes this type of testing to the American Welding Society. And it really opens up their eyes a little bit more to see that okay, this individual might only have 160 hours in a training program, he has no prior experience, but he has skills that can pass a test like this. So you still might only be doing production work, but it gains you the skill and the knowledge as you move forward to get that job in a structural shop doing structural steel. And mostly of those, you're not gonna be doing open woods like this, you're gonna be doing fillet welds on structural steel. So
That's what a lot of MIG welding is, but they are getting into doing MIG welding out in, like, I was just on blast furnace job at Zug Island, and the Boilermakers were in there MIG welding.
Yes.
On the side of the wall. So they're, as technology gets better, they'll probably start MIG welding more.
Well, that's why, if you see that machine in the corner, that Pipeworks 400, that machine alone is about a $20,000 machine. Before, they never recognized doing MIG, on pipe, for the process piping. But, in small shops, various things, they would use MIG, for that. But now, since Miller's developed this machine, it's a RMD machine that you can take and put a root pass in pipe, almost just short of what it takes to put in.
It looks about the same.
Fabulous. It's
And it's a lot faster.
And now it's all about speed. So in the old days, they would do a lot of assembly of stuff on the job site. But now they're starting to do a lot of things in components or on skids.
When I work out on the job and we're doing like whatever, something new's going in, they'll make most of the stuff at the fab shop. And then the welding you do out in the field are tie-in welds, and where the welds, you can't make something that goes up and over and under, and you gotta weld it eventually somewhere. So they do a lot of. It doesn't come. You don't want to. I mean, if they send you something like that, the pipe will be beveled. It's not going to be prepped. They won't do that. A lot of times they cut it with a torch, and
You
it's
have
all
to
over the
re-prep it.
place, and
And re-prep.
you gotta prep it with a grinder, and
It's not gonna be.
Okay, so, Steve Mike is ready to move on here.
Yep.
yep, I'm gonna tack this
See what
little,
he's doing
cover
now.
your eyes.
Shoes down.
Stubborn.
And that's just the holder to it still.
Yeah, I'm just putting that
It's
there
like the
to,
thing I was doing yesterday, so it could be clean.
Mike is, excuse me, Sean.
You gonna get his name, it's
I'll
good.
get his name right here, probably in about another 10 years.
yeah, it'll
But
come off.
Sean is putting this little bracket on there so he can get out there to make the weld. When we start working on our plates here, I'd rather you not take and put that little tab on there, because where that tab is at, we have to cut sections out for your bed set. So he's doing this now for
I'm just doing this for the
demonstration
sake of
Demo.
demonstration.
All right.
On a real test, they usually don't want you to mess with it too much. All right, so what we're gonna do, this is the first pass, this is your
Now
root
this right
pass.
here, you really want to get around there. You can
Don't
sort
be
of watch
shy.
both sides. You can watch the front side, how his manipulating technique, and he's not doing a lot. And then look at the back side, and you can see the penetration coming through that back side. Hang on a second. Judy, yeah, get right over there.
Yeah, you guys will wanna try to over, like around this part of the table would be
Yeah,
good, because then you
around.
can see the back. And I can stop and you guys can switch, so you one person, 1 second see the back, and the other second see my side. So what you're gonna do here, this is, like I said, this is your root pass. Now, if you guys do everything right, this should be exactly the same every single time. Now what you're gonna do is, you're gonna run this bead in here, and you wanna keep your about a
stick
quarter inch, your stick out to a minimum. About, I mean, you can't get real in there, so it's gonna be about a quarter inch,
Remember, same
which
thing we
changes
were
as you
talking
come
about
out.
on our other welds, about a quarter inch stick out.
On these MIG welds, you're able to come out a little bit, but you don't wanna be way out, cause then you're gonna lose your gas coverage, and I'm sure you guys went all over that. But what you gotta do is you guys make sure this is gonna be, this pass is very quick, and you're not gonna be able to see a lot of the puddle, but it is there, so look very closely. And what'll happen is you can start to see if it's gonna start burning through, or the front will start building up. Once that happens, you can tweak yourself just a little bit to make sure it doesn't grape out on the back, or
That's
you
working
get
with your travel.
lack of penetration.
Oh, about what type of an angle? Show about what type of an angle.
So you guys are gonna be going vertical up on this root pass. You're not gonna be doing this down. Sometimes you do down, but on this test, you're going up. So you gotta remember, you're trying to build up a root. So if you go up, what's gonna happen is, what can happen is this wire will be, welding along, and if you make a little hiccup or something and this wire leaves the contact of the metal, what's gonna happen is it'll burn back, and then it'll cut it off when you correct yourself, and then you'll have wires sticking on the back of your root.
That's what they call whiskers.
So
say
you don't
bunch
wanna
of
have
wires.
that, because they're not even gonna let that go to a bend test. They're gonna look at it and say, no, sorry, you didn't make it. And that'll be it. You won't even go on with the weld if you have that. So
So-
you wanna
How
have an
much of
angle
How much of an angle, Mike?
down, pointed down towards your
What down into your weld?
so
pump?
that when you're welding, you're gonna have your puddle there, and you're gonna see all the puddle. You wanna keep the wire pointed down at that puddle, and you wanna keep it only about 5 degrees, 5 to 10 degrees from 90 degrees here. So, but make sure you're pointing down. Once you start going straight in and up, you're gonna start cutting it off, and like I said, you can't pass that way.
Because you have to build on that puddle as you go up.
Now, you don't have a lot of material down here on the bottom or at the top, so the heat is gonna be a factor there. So when you start this out, you might need to just kind of build it up a little bit and then start. But again, when you do these tests, you get 1 inch, right? 1 inch?
Yeah, 1 inch top.
You get
and
1
bottom
inch
cut out.
from the bottom and top that's for tacking, that they're gonna cut out, and that's not allowed to be tested.
Because another thing.
They wanna have a good, nice, clean weld. They don't wanna have these tacks, so don't worry too much about it.
Well, what happens is, if you remember, I said that when you start your weld, everything is cold between your metal and your wire and stuff, and it takes roughly a quarter to half inch before everything heats up good. You start getting that good full penetration. So, you know, that's really critical as you watch on the beginning, that you don't really, jump up, because then the farther you go up, the further that you'll have that lack of penetration.
I'll weld just about roughly halfway, and then whoever's back there can come over here, see what it looks like from the front.
So you can
Again, if
rotate
you guys,
from the front
if you
and the
see
back.
me moving a little bit, I'll try to explain what I'm doing. Hopefully we don't have any problem with that, and don't have to do a lot of moving.
Hands down.
So watch your eyes.
Hold on, y'all. Y'all
Everybody
got
all
that?
right?
Y'all in the way of the video. Come on, man.
Here, wait a minute. Let Janae get over there over Mike's shoulder if she could. That way she could get a little better view of the video.
All right, I'll try to
I got you.
manipulate myself so you guys can see this a little better. I'll put myself over here a little bit. Again, guys, when you do this, make sure you get comfortable. All right, you don't want to have your arm all cocked up and trying to get yourself comfortable so that you can do the whole weld. What I like to do is I'll go right to the center, and then I'll go down and make sure that I can make it all the way up and down, which right here I have the ability to do. All right, you guys ready? Cover your eyes.
Shoes down.
All right, this has got a little bit of a wide gap than what I usually like, so I'm going to put a little bit of a weave on it. John, keeping my wire pointed down to the puddle. You don't want to start coming up or straight in because you'll cut it off. Another thing with MIG welding is you want to listen to the puddle as well. You start listening and seeing the differences, or I'm sorry, hearing the differences between what the wire sounds like. All right, it's starting to skinny up a little bit, so I'm going to stop my weave a little bit. You can see the back side a little bit from the front. Stay right on that puddle and move up real nice and evenly, slowly. All right, so that's roughly halfway. Should have a bead on the back side. Still need to come out a little bit more. Need to tweak that a little bit. Another thing, guys, when you're doing this here, you want to, you're going to put a bigger tack on it. This tack right here is wanting to pull it together a little bit, which is why it's doing what it's doing. So if anybody wants to move right now, feel free to do so.
Later on, what we're gonna do is show you when you put the heavier tack.
I got you.
The feathers and tacks, to blend them down before you can start to come out of that tack. Still get the good thing.
He's in my
We don't want to
bottom.
throw too much at you at one time right
You
now.
guys? You guys have all that?
All right. Everybody good? Yep. All right. We lose our ground?
Probably.
Yeah, we're good.
I don't know why it's doing that now. Yeah, it's smooth. Stay right on the puddle. I still would like to tweak this machine a little bit. But that's all right. You guys got the idea. All right, so when you guys come to this pass, I'll start speeding this up a little. Trying to keep this in a relatively good amount of time. This is where you take your grinder in.
I'm gonna get some wire wheels in here also.
You want to smooth this out. And I'm only going to do half of it because it takes too long. So get yourself at an angle that you can see in there. Let me change this.
Pull that little lever up, Mike. I mean, Sean. I'll get it for you.
You get it right one of these days.
Huh?
Oh, I just didn't want to be rude and get in front of you.
You guys are all right. All right, so real quick. Good to get 1/4 inch wide grinding wheels too. For the sake of what I'm doing, that's going to be good.
You probably noticed that, Mike, did you have a little bit of a hump there where you took and made your tie-in?
Where I restarted?
Yeah.
Yeah, it was a
So-
little built up, so that'll happen. But again, I mean, on this, tacks need to be changed just a tad bit. I just want to give you guys what you're going to be doing.
But that's another thing with the grinding.
So feathering the tacks and making the tacks the way they need to be, because you have a certain amount of distance, all that's why you get like 3 hours, because it does take a little bit. This is the part where like good grinding and whatever comes into play. You guys gotta make sure you want to grind this down, but you don't want to go too thick, because then you're getting thin and you're gonna burn through on the backside. So keep the grinding and watch the center. You want to just make it nice and flat. So you're gonna have your angle here, and then you want it flat. So you grind down to it to where you see these two edges here, wagon tracks or whatever
There
you want to
go.
call
That's what I
them.
was gonna say. That's what they call those.
They call these wagon tracks because when you're in the mud, wagon wheels make a nice whatever in it. So you want to keep in mind on that, and you don't want to go too thin. If you guys are starting to see the metal start to change colors really quickly, going through all the rainbow, that means you're going too thin and you're going to burn through. So you just want to keep it come down to where you take this hump down, nice and straight across.
Mike, would you mind if we jump in for a second and take a look at that?
What do you mean? Oh, I'm
they
sorry.
wanna
Yeah.
step in
No,
there
it's
and see.
okay, we just can't
I'm
see
sorry,
the back
guys.
here.
Yeah.
Thank you.
So you see these two? I'm in the way like a goofball. I didn't even realize what I was doing. All right, yeah. Like I'm saying, see, just come down, take this hump down. You guys can see what I have here, as opposed to this here. You want to come down nice and
Just gonna
straight.
touch the screen
And you can
or
see
turn it off.
that I didn't go too much to where you're taking too much off. And from here, you would take a little bit more off just to get these two lines from the edge of the welds.
Right.
Smooth that in. But like I said, for sake of time, we're not going to go crazy on it.
One more pass over here or two?
You're going to do two more passes.
The second pass
There
is-
are different ways to do this test, certain techniques, but we're going to do just like you would do on a stick test. You do your root, hot pass, and cap on this thickness of metal. It does change. Now, if we were on 1/2 inch, you're going to have probably 4, maybe 5 passes on it.
Depending on the thickness of your
Thickness
material,
of the
that
metal.
you just put the amount of passes in that it takes to fill it up and to get your cover reinforcement.
Sean, this is a 3G test, right?
This is 3G.
3G means 3
Yep.
passes, right?
No.
3G is
Vertical. It's a position, which is
It's the
vertical.
position given by AWS to each test.
Designation.
So 1G would be
Flash.
G means groove, and that's all the bookwork stuff. But real quick, G is groove, F is fillet. So if they say you're doing a 1F, you're going to do a flat fillet. If you do a 1G, you're going to do a flat groove weld. This is a 3G, which 3 is vertical, which means it's always going to be vertical. It never changes. It's not 3 pass or anything. So if you're doing a weld that does 5 passes, it's not a 5G.
Okay.
5G is a stationary pipe from bottom to top without spinning the pipe. Once you spin the pipe, it starts to be either 1G or 2G, or not, can't be 2G.
On pipe, it goes from 1 to 6.
Yeah, everything, it goes 1 through 6 on F, 1 through 6
Well,
on
except on
groove.
pipe, there's no 3 and 4.
If somebody says 5G to you, that is pipe. It's never plate, ever. 1
You know
through
what?
4 is
Now,
plate.
with those questions right
5 and
there,
6 is pipe.
we'll review a little bit more of that in the book.
Okay.
To where we have a better understanding of it.
Yeah, because I think he's about to do another pass.
Okay, so what you guys are gonna do
Get it on
is
the
a
video.
weave. You're gonna weave it back and forth.
What's that, sorry?
Weave it back and forth.
Okay.
So you're gonna go from side to side. You gotta make sure you're going nice and smooth.
You're gonna hit
Pause
each side
on-
of that wagon track?
You're gonna see that I'm gonna go outside of that as I weld it. You'll see what I mean. So what I'm gonna do is about right here for sake of time and everything, like I said. When you weave this, you don't wanna put any circling in your weave. You don't wanna up and down. It's basically like take your finger and
Almost like a
as smooth as
seaweed.
possible. You don't want to go too far up because then you'll start getting holes. They look like holes underneath of it. And if you're too tight, it'll just build up and be a big mess. So you want to make sure it's a nice even step. You can step up higher, and some guys do it. Some guys weld where their stuff looks real spread out. Other guys weld and it looks real tight. It all depends on how you want to do it, but you got to be consistent with it. And you can't do it to the point of creating weld defects.
Okay, Mike, one more thing. On this hot pass, how much metal do you put in?
You are gonna wanna put.
For the video, this man's name is Sean.
About, let's see, with
Just
MIG
below
welding.
the surface.
You wanna put about a 1/16 below the surface of the plate. Cause when you do the cap, you have from flush to 1/8 build up on the cap, so you'll have enough room for that. You gotta have a place for the cap to lay in.
Are you allowed to grind your
What
cap?
happens is, what happens.
You're not allowed to grind your
No,
cap.
no more grinding after that root.
You don't wanna grind your hot pass either.
What happens is on that hot pass, the second pass, where you want to be about a 1/16 below the surface, don't come out to where you're eating into your bevels, into your plate, because then you've got a real crook and you have a hard time following it. So as long as you stay a 1/16 below that surface, you have edges to follow.
Yes, that's another reason to keep good edges. Gives you something to follow on the cap. Do you guys understand what is meant by below the surface of the metal? Do you guys all understand what we're saying? Okay. That's what I make sure. Now remember, when
Can you explain that, please?
when you do the, what was that?
Can you explain what it is? Just in case, people don't want to
Okay,
say
Here,
it.
let me see a
What it
piece
is
of that. Let me see a piece of that your plate there,
If you
Mike.
take this, if you take it like this, just go crazy with it. Chalkboard would be perfect right now. You got your bead in there. Okay, so it's gonna look like this is,
It is show them the hot pass.
okay, so this is the thickness of your metal, so that is this right here. This is what you're looking at. This picture is that. So on your hot pass, once you get it ground down here, your hot pass, you wanna put, and you want it to be below, about a 1/16 below the surface of this plate. Do you understand what I'm saying?
Yes.
So you give yourself, when you do this, when you do your cap, it gives space, because MIG welding will build up fast and quick. So you want to give yourself enough space from the hot pass to the cap, so that when you do the cap, you don't get crazy. You'll burn away this edge a little bit, and the weld will go in there like that, and it has somewhere to lay down, so to say, and also edges to follow as you go up.
Okay, and one thing, Mike, how wide should that cover pass be?
It shouldn't be any more than 1/8
To each side of your
of
bevels,
the toe of your weld or the edges of the weld.
edge of the bevels.
So when we talk about the toe, you're talking about the edge of the weld. And that's in your guys' book too. It dissects and tells you all that. But yeah, you don't want to be, so 1/8 would be this thickness right here. Take that to the edge, and you don't want to be any wider than that on your cap. Okay? On your hot pass, you guys don't want to give yourselves undercut on your hot pass. You know, sometimes you'll be like, oh, well, it's my hot pass, I'm gonna fill it in anyway. But you don't want, that can make you fail. So you want to be able to have a nice smooth, no undercut on your hot pass either. Let me see if I can
All right, it's good.
give you guys a
You got it?
little bit of a reaching so you guys can see it.
You didn't know.
Make sure that stays vertical too. All right, so
There is one thing, Mike, Sean, excuse me, Sean.
it's all right.
You got two names today.
You can have a little bit of a tilted back angle from
Yes,
vertical.
the angle going up.
The
That's
angle
right.
going up, you can have a slight tilt on it, no more than maybe about, maybe 2
5
to
to 10
5
degrees.
degrees.
I do 5 to 10. I like
5 to 10.
I like to be about a 5-degree angle. So
No,
remember
not-
when you were
no,
on your,
not-
you're
not
talking
on
about your
your-
travel
no,
angle.
not on your, that right there, but your plate itself.
Oh,
You know,
that
for
okay.
vertical straight,
I see what you're saying.
sometimes that if a person's having a little bit of trouble trying to go up like that, then, well, we can tilt it off center just a little bit from the vertical, and there's like maybe 2 to 5
Like that.
degrees that you're allowed for that little bit of backward angle.
Yeah. Yeah, I always forget about that one. But your angle, remember, on your root, you're pointed down 5 to 10 degrees. When you're going vertical up, you're gonna do opposites. Your cup's gonna be pointing up 5 to 10 degrees. And what Don was talking about is this angle here. You can tweak it on an angle from 0 to 5 degrees there.
So you're doing a pull and push pass in the same test.
Yeah, I guess you could say that. You could call it that. I just just remember when you're doing the root, you want to point it down to help keep that built up, and when you're going up, you want to point it up as the travel. Just like if you were on a horizontal lap weld or something, just want to push it like
That
that.
right
If
there
you're a
could be
pusher,
considered a drag up,
Okay.
because they're letting your puddle, your weld metal follow your wires, you're coming to the top.
all right. So what I'm going to do here is I'm going to keep myself 1/16 below the surface and keep it wide enough to where I'm not getting any undercut, and it's not gonna be a real convex cap. You want it to be as flush as possible. You can have a little bit. You don't want it to be concave either, to where you're underfilled. Ideally, you want it straight across, but we're humans, not robots, so it's gonna have a little bit
Well, we're not, but he is.
crown. I don't know.
That's what he says.
All right, so this is your second pass. You want to make this as good as your cap. Start off, like I said, and build it up. Now I'm giving myself enough bit that it's building up. I'll pull back a little bit. Keep that angle straight. When you get to the toes of your weld, you want to pause for a second. That's what I mean about the liner.
Oh, darn.
See how it was kind of burning back a little bit?
Came in like a boss.
Now this isn't, I'll be honest with you guys, this isn't the way I do it when I do the cap. I do a different technique, but I don't want to show you guys that because it gets complicated. But when you guys start getting your, when you start getting used to it, I can show you guys what it is. So then now we're gonna do the cap. Like I said, you don't want to go any wider than 1/8 of the edges of the weld. When you get to the toe or the edge of your weld, you want to pause for a minute. Make sure you don't undercut it away. Because if you undercut it away, that's gonna definitely fail on bin testing. Because when they do this,
So this your needle, this the gun. So you're doing it like this.
No, you don't want to have this pointed down on your hot passing cap. You want to point it slightly up. That's why this gun has got an angle on it like this, so that you can, when you're going up or down, your angle will be good. So you want to, so if we're at 90 degrees or whatever right here, you are allowed 5 to 10 degrees, but pointed up.
We're going from the bottom to the top.
From the bottom to the top, pointed, it's gotta be pointed up from the bottom to the top. Yeah, you're not gonna be going like this. Okay, you wanna, think about if like a robot was doing it. A robot's gonna stay in one spot and do everything perfect.
Oh, go straight.
So that's how I always thought in my head, like how would that do? So you wanna keep everything the same all the way from the bottom, all the way to the top. Because if you do this, your whole weld's gonna look completely different.
Don't do like a C, do like a line.
Yeah, you wanna go back and forth in a Z pattern. No, you don't wanna. You can do a slight C this way. As you go up, you can do a little bit of the C if you want, that's fine. Some people do it that way. That's how my welding teacher in high school did.
Hey, Sean,
You don't like the C? You want, yeah, you can just go straight across in a Z pattern if you want.
hey, Sean, what about like in circular motion? Like a little,
If you're doing like a horizontal,
like you're doing a vertical up, like
Oh, yeah, can you do the E's?
no, you don't want to do it that way. No, that is for horizontal. On vertical, if you start doing that, you're gonna start, that creates inconsistencies. And you don't want to do that. You want to keep this straight in a Z pattern from side to side, pausing in the corners, same angle from the bottom to the top. And that's it. Right speed and everything. Now I'll do the cap real quick, just half of it. Like I said, you
What do you
want
allow on your third pass above the steel? 1/8?
1/8. It's flush to 1/8.
Flush to 1/8.
Yeah. All right. Watch your eyeballs. Build this. I can see a little low on the bottom here. Just build that in a little bit. All right, here we go. Make sure you don't keep it too tight. Pause for just a second. You guys see that? Just try to move a little bit. I want to make sure everybody can see what I'm doing. Trying to give you guys enough room to lean back so you guys can see what I'm doing. Does everybody see that? What I was doing there, just side to side? When you're doing this test, don't stop. Try to do it from bottom all the way to the top. Because then if you try to do a pickup on MIG, it's a pain to get it to smooth in. If you can't use a grinder, I put all the money I've ever made on the line saying you can't smooth it in. So you want to try to go from bottom to top. I just stopped to make sure everybody could see what I'm doing. I'm trying to lean back as I do this. And actually, if you take that bolts on that machine over there and just tweak it up like 200ths, like maybe, what is it at? 16.2. Go to like 16.5. It's a little bit cool. I didn't get a lot of time to fool with it. I'd take a little bit more time to set this up before I did my test. I changed some things around. But I'll start from here in case, if anybody else hasn't seen it, come over here and take a look so that you can see what is going on.
I'm gonna watch it.
You guys all moving around to make sure you can get a little bit more. I could run a little bit more in there.
Can you do this? So I was trying to let other people see it. Well, take the shoe.
Did anybody not see the hot pass? The way that was done?
There you go.
I don't want to give you guys too much. You still got to prep everything. And another thing, guys, he's going to get some wire wheels to do this. So after each pass, like when you get done with this hot pass here, you want to wire wheel it. And then that helps a lot too to smooth it in. Like I said, I didn't get a lot of time today to fool with this machine. I would tweak it around. It's a little bit cold for what I would like to do. But you guys are getting the idea of what's going on. We can fine tune things later. So I'm gonna do it just a little bit more to make sure you guys can see the cap. So cover your eyes. I just wanna let you guys know I'm not showing you a pickup on this. I'm just gonna do it for the sake of people seeing what it looks like. All right, cover your eyes. You see how it's kind of like going and changing a little bit? That's the liner. That's why you got to make sure this is straightened out. But that's it. That's basically what you do. Like I said, there are other ways to do it. I'm sorry if did that land right in your face? I'm sorry if it did. There are other ways to do the cap, but you want to pretty much do it the same way. Weave back and forth just like you would with like a 7018.
You would normally, like you grinded out that bottom ground.
Yeah, you want to grind it out on